Now, before we get into the lecture this afternoon, let me present our speaker, Steve Veatch. Originally from Colorado, Steve Veatch and his wife moved to Michigan, where he continues to enjoy the outdoors, research, and write history. Or let's try that again, about history. Steve volunteers for the Benzie Area Historical Society, works in the archives room scanning photographs and documents into the online catalog. He chairs the collections committee and is the vice president of the board of directors. Please join me in welcoming Steve as he presents Benzie County during the Ice Age and how glaciers shaped the landscape.
Thank you, everybody. It's great to see so many people here that like rocks. I like them too. And I got my earth science degree late in life. I was in my 40s. And then I got a chance to teach in the special programs and continuing education department at the Colorado School of Mines. And I teach now at NMC in Traverse City. And I've done research on the Little Ice Age in the fluorescent the Little Ice Age in Colorado by studying tree rings. I worked with the Fluorescent Fossil Beds National Monuments mammoth that was found there. With Ice Age pollen, I got to do quite a study on that. And I did research on fossilized trees found thousands of feet below the surface of the earth up at the Cripple Creek gold mines in Colorado. And just to give you an idea of where we are in time, because this story is about time, I'm going to stretch out my left arm, and where my fingers are on my left arm, that is where when the planet started. And over here, where my index finger is, right in about the middle of it, is where the dinosaurs went extinct. So this is, and at the very end of my right hand on my fingernail is where man appears. So we've been on this planet a very short time. And when people say the Ice Age, we think of only one, the one that we're coming out of right now, or maybe going back into another one. But there were a number of ice ages before us, at least 6 big ones. One when the entire planet was a snowball. So you can see this graph, and everywhere there's a blue dip, that was an ice age. And there's evidence for this ancient ice age that happened 2 million years ago all over the area, and that's the Galgonda tillite. And that was formed up in Canada when a glacier was up there 2 billion years ago, and it would drop these little pieces of pink granite into mud. The ice was calving, and it would contain these little rounded pieces of granite. It would drop down into the water, go through the water column, hit mud, and just lay there and then be absorbed by the mud. Then over time, it turned to stone. And then the more recent ice age that we think about came down in Canada and brought it down to us. And they melt, and they're all over the place. And they're quite valuable now. They're hard to get. You have to pay a lot of money for them on eBay. And I just told you about that. And they're quite distinctive. You can see the little pink class in the mud from 2,000 years ago. I found that one in the rock pile, the landscape rock pile on the walkway into the Interlochen Public Library. And so I took it in and told them, can I trade this for another rock? And they said, sure. So that's where I find my Galgonda tillites. But they tell a story of a 2 billion year old ice age. And they're so interesting. This man took it to his grave, and that's a tombstone made out of the Galgonda tillite. Climate change is a feature of geologic history, and it fluctuates between a greenhouse and an ice house. And we do have proxies for scientific evidence that make global warming easy to discern. So if you want to know if there is proof positive of global warming, I will present you the tools that we use. Yeah, I'm sorry. So there's a number of reasons that ice ages can be caused. Sometimes they work together, maybe independently. One would be sunspots. When you have more of them, it's warmer on Earth. The sun is a lot stronger. Fewer sunspots, it's cooler. It's just the opposite. And as time goes on, the sun's output varies over time. And the longer the sun burns, the hotter it gets. The sun today is 30% hotter than when it began, when the planet was formed. This is a chart or a graph of observations of sunspots. And you can see we're in a period of maximum sunspots. Volcanic eruptions can cause changes in the global climate system. And you can have the greenhouse effect with increased CO2 from those volcanic emissions. You can also get it by burning fossil fuel. There is a way to decrease CO2, and that's the chemical weathering of igneous rocks. Also, plate tectonics, as the continents move around, they can affect the climate, and also changes in the circulation of the ocean. And the more recent ice age, the one we're either in or out of, is caused by astronomical causes. One is that the orbit around the sun changes and it can get closer, it gets warmer, further away, it cools. And then the tilt of the Earth, changes in the tilt can cause changes in the climate and the precession or the wobble of the Earth. The wobble will change a little bit, and that will cause together an ice age. And the one that I'm talking about, the most recent one, began about 2.5 million years ago. And the ice sheets advanced and covered much of North America. And that's what it looks like about 12 million years ago. A closer detail showing North America. And it ended about 11,000 years ago. It was such an important period of time, so impactful that it got its own name, the Pleistocene. And when we say ice age, we think about one moment in time that's frigid and cold and nasty, and that's not true. You can look at this chart and it shows a number of interglacial periods where it's very warm or warmer, and there's at least 28 of them. And there was a period of time where there were at least 28 cold periods. So it fluctuates back and forth through time. And we might be going into a very warm period right now, followed by a cold period, or we could be leaving leaving glacial times completely. Here's the extent of our glaciation in the last ice age. There was Wisconsin, Illinois, Kansas, and the Nebraskan. The bottom two, the Nebraskan and the Kansas, are now called pre-Illinoian, and they base everything into the three time frames of ice covering the continent. When a glacier moves across the landscape, it tears apart and reshapes the terrain that it's going over. It picks up stones and debris at its base and grinds those pieces for miles, streaking and marking and grooving the land it flows across. Here's a cartoon of Michigan, and you can see where the ice was 7,000 years ago, 9,000, 14,000, and 20,000 years ago. And it just didn't go and come back. It would go, come back, go and come back, go and come back, the ice sheets. Now let's look at the Benzie County features. There's two areas to think about when we look at this, and that's the area of scouring or erosion. The other is the area of deposition. We'll look at erosion. And the first thing I think about would be the Great Lake basins. As ice advanced in lobes down pre-existing valleys, these lobes of ice deepened and enlarged the pre-existing basins to form the Great Lakes. And one interesting thing is Lake Superior, it has such a deep basin because it was at a spot where North America was actually being torn apart. It's a rift zone where there's a lot of weakness there and the land is spreading apart. Michigan, our state is, Michigan's location is at the confluence of 6 glacial lobes. This arrow points out the end of a glacier, or it's called a terminal moraine. If that's as far as it gets, that's a terminal moraine. As it starts to retreat and go back because weather is warming, that's a recessional moraine. Along the side of a moraine it's called the lateral moraine. When two lobes come together, that's called a medial moraine, and it will dump material down from the edges of the two glacial lobes that are attached or coming together. And then a lot of what we see around here is a ground moraine. And you can see the rift zone that was there at Lake Superior and the gouged out areas that became the Great Lakes. Take a look at these cartoons that I put up here for you. This is 17,000 years ago, and the light blue is ice. 400 years later, it starts to go up, goes up a little more, comes back at 15,900. It is completely almost out of the state of Michigan 14,000 years ago. Then it comes back. It hits Benzie County where the blue arrow is. The lake now is risen, Great Lakes. The ice is further north. The ice is further north even more. And Lake Michigan is drying up. More of the same. Then it gets full again. It goes over the modern day borders. And that's what we're left. So those are the big erosional features in Benzie County. And this diagram gives you a relative idea of the depth of each Great Lake. And Lake Superior is the deepest because of the rift. When glaciers are moving over a landscape, the bottom of the glacier is full of rocks, and if they hit rocks that are underneath them, they will leave grooves or striations. This is not from Benzie County. This is from Marquette in the Upper Peninsula. But I got a really cool striated boulder that shows this. That was from a Sleeping Bear Lake National Lakeshore. And you can see that the bottom of the glacier was grinding over the top of this piece of dolomite. So we've looked at erosion. The next feature is deposition, and there's a lot of that in Benzie County. We have two kinds of things being deposited. Drift, which is a glacial deposit that has been influenced or been worked by ice and water and released when ice melts. Then till is deposited directly by ice. It's unsorted and it lacks layering. Here's a map showing thickness of the glacial till in Michigan. And brown is the deepest, and you can see Benzie County has a pretty thick level of till. Two of the big ones, big moraines in Benzie County is the Empire Moraine, and the other one is the Frankfurt Moraine. And then the rest of it is ground moraines, and that's very hummocky, hilly, rolling hill type of topography. You also get some other cool depositional features. You get drumlins, which we don't have in Benzie County, or eskers. We do have cames, we have erratics, and we have kettles. We also have lacustrine or lake deposits where Lake Michigan came up to where Crystal Lake is today. And when it began to recede, it left lake deposits that you would normally see with any lake. Perched dunes, these are sand dunes up on the tops of moraines. And I've got some really good pictures of that in glacial erratics. This cartoon shows eskers. They're like winding piles of dirt that come out of the tunnel in a ice sheet, and it fills with sediment, and it leaves these twisty, turning sediments, and they can have a delta at the end. But we don't have any of those in Benzie, and we don't have drumlins, these little hills, and they form in clusters. They do have them up in Leelanau. Look at that field of eskers. So here are these terms again. The ice is receding. At the very bottom, there's a moraine down there. That's a recessional moraine. Falling ice will get into the top of the moraine. Big blocks of ice, it will melt, and it will leave a kettle lake. There's the end moraine, that as far as that moraine got. And remember, the moraine is full of rocks of all different sizes. As the moraine, as the ice recedes, it leaves recessional moraines that's dumping out the front of the glacier as it melts. And it also creates outwash plains. Just imagine lots of flowing water pouring out across that outwash plain. And there's a little esker, some drumlins, outwash channel, outwash plain. All that water is sorting all that sediment, all that material. Let's take a closer look at Benzie County. So here's a timeline, and we can go back to about 2 million years, all the way up to 1873, when Crystal Lake was lowered by the Benzie River Improvement Company. The Lake Chicago stage and the Lake Algonquin stage, the Nipissing, that's referring to the size of Lake Michigan. I made a number of interesting discoveries when I was working on this project. And one was the history of mapping of these glacial deposits in Michigan. And the early work was done by Frank Leverett and Frank Taylor. And what they produced was just a masterpiece of geological literature. And they had beautiful geologic maps that they made by riding horseback and walking over the terrain of Michigan to come up with these maps. Not much happened until the 30s and in the mid 50s when Helen Martin, who was a pioneer geologist, made maps. Few women attended college in the early 1900s, and fewer still went to study geology. And in 1982, Ferran made a really nice map, and I'll show you some of these maps. There's Helen Martin, and here's her geologic map. And each color represents a type of rock. And she did that one in 1955. Here's a close-up of Benzie County. So you can see Crystal Lake, and the dark brown are the moraines, and the butterscotch color are the outwash plains where the ice was melting and all that water was rushing out and picking up and moving rocks and sorting them, putting them in layers. But there's more detail. There's more detail, and that comes in 1982. And there's a real story with these maps. And Stacy Daniels and I are going to dive really deep and find out more about those two guys that rode horseback all over Michigan. And we're going to find out more about Helen Martin. And we'll be back November of next year and tell you more about these really interesting people and maps that they made. So you can see a lot more colors than Helen Martin's map. You can see that there's a moraine with a coarse texture. Then a medium texture is green. Really coarse is yellow. The pink is glacial outwash. And that kind of military green is a coarse textured moraine. So you have a lot more detail. Now, how do you get these different textures? You may think. If it's a really fine-grained moraine, it has been experiencing a very long transport all the way from Canada down to here. It's been grinding and grinding and grinding, and you get a finer grain material. And the rock source could also be shale or siltstone, which is soft and will pulverize. If it's a medium grain moraine, it's moderate grinding and mixing. And if it's coarse, full of bigger rocks and material, it's had little grinding, it's short transportation, and it's probably rocks that are granite. What are Benzie County's notable geological features? The most obvious is Lake Michigan, scraped out by ice. The Sleeping Bear Dunes National Lakeshore, they have part of their property in Benzie County. Lakes, we have 54 lakes, embayment lakes or kettle lakes. We have plenty of moraines that I've talked about, and the outwash plains. We'll talk about erratics. Erratics are depositional features where the glacier, if you look at the top cartoon A, it's coming out of Canada. it picks up a boulder of sandstone and it moves it down, and it melts and it drops that sandstone on a limestone that doesn't belong there. It's called an erratic. And doing some field work with Matt Barnum and Jane Perkis last year, we went exploring in Benzie County, and we found possibly the largest erratic in the county. And there it is. And I believe that is a granite. And this is in the park in Benzonia, another piece of granite, all carried by ice from Canada. And the ice melted and it just dropped. Jane and I went and did some field work a few weeks ago, and we found an erratic in front of this guy's house in Frankfurt. These are really exceptional erratics, pudding stones. And there's an erratic by one of the camps, early camps, and a young camper fishing. You can also call the smaller erratics field stones. In Michigan, the History magazine dedicated one of their magazine issues to field stones. These are erratics and field stones that you can see from our photo collection at the museum. This is interesting. Look at this guy's fireplace. If you look very close, you can see a depression in there. That's been made by someone grinding some kind of material in there, a Native American. And I even found what they were using to grind, the grinder right there. So there's an artifact in that guy's fireplace. I don't get much work done when I help Sherry at the museum. Every Friday, I'm supposed to scan these historical pictures into TIFF document images so that they're protected forever. And I end up looking at all these pictures. There's so much to look at. And the more you look at these old photos, the more they tell you. There's some more erratics and field stones. 2 little kids and a dog. Jane and I went on this same field trip. We went to Alberta and found some of these field stones, erratics. This is amazing. Look at the detail. I've never seen anything quite like that. So this is a way you can rock hunt. I wanted to go up there really bad and explore that guy's wall, but I didn't want to get hauled away by the sheriff. So I blew up the picture, and right there is a metamorphic rock. That's migmatite. It's under a lot of heat and pressure, it liquefied, and you can see little streamers of molten material running through other parts that didn't quite make it into liquidity. And there is some limestone, some sandstone. So all kinds of different lithology here. But it is a cash crop for some farmers. Look at this thing. This is a Rockies picker. I need one of those when I go rock hunting. And you drag it along your field and you make your piles of field stones and erratics, and then you sell them for landscaping, to landscaping companies or stonemasons to make fireplaces. And another area of deposition that we have in the counties is sand and gravel company. Cames are made when there's a crack in the ice or a depression, and it begins to accumulate sediments, and then the ice melts and it just leaves a plop of sediment. It's like a gopher hole, those mounds you get in your yard. It looks like that, only it's giant. And ski hills in Michigan are usually caves. Crystal Mountain is a cave. And this is a topographical map that shows the relief, and there's the North Hills. So a real interesting depositional feature. You can see the profile here at the bottom of this Google map. You can see how steep it is. And Crystal Mountain, North Hills. The other thing I'd like to talk about are these outwash plains. And you can see they can fill a whole area, flatten a whole area out, and leave a sorted type of till. And then there's usually running water, rivers associated with them. Here's another outwash plain up by Platte Lakes. Here's an outwash plain down here. Just think of giant pieces of sheets of ice melting in the water, running and leveling the land and leaving deposits of sorted materials. Lakes, there's a lot of lakes in the county. There's more than 11,000 in the state. And we have really two kinds of lakes, glacial lakes that are from embayments. Those are old bays of Lake Michigan that have been cut off. And then the kettle lakes that I described earlier. Upper and lower Herring Lake is an embayment. Benzie is a lake is an embayment. This whole area here is an embayment, and so was Crystal Lake, and it was cut off from Lake Michigan about 2,000 years ago. This map is a little bit more detailed than Helen Martin, and I think it has more detail than Fran's map. And you can see the Frankfurt moraine, the Empire moraine, the Betsy moraine. Crystal Lake sits in between two moraines. And Frankfurt's on a ground moraine of about 200 to 300 feet thick. If you look at this, the yellow shows where Lake Michigan came into this part of Benzie County. And the yellow was probably the limit. The yellow also, all around that yellow are wave cut bluffs. And they were cut by Lake Michigan when it occupied that area. And here's some old beaches. And swamp. This is a classic example of an area that has been cut off from the lake. And we end up with Platte Lake, the Platte Lakes, and old beaches here. I talked about kettles. Here's a good example of a big piece of ice plopping down into the moraine, the sediments. It melts and it leaves a hole for a lake to form. Mud Lake and Rush Lake and Lake Ann, I believe, are good examples of kettle lakes. I'm not sure how many natural lakes we have. Natural lakes are a rare feature on the landscape. Most of them form from blocking a stream valley. The only process that formed widespread lakes is glaciation. Engineered lakes are common in Michigan and have changed sedimentation rate due to the dams. And I bring up another map. We got a lot of cool maps at the museum, and they show us a lot of things. And this is an older map And I'm calling out to you Grass Lake and Lake Ann and Pearl Lake, and those look like kettle lakes. We got a grant this year. We had a student, MSU student, come in as an intern, and she was taking these really old maps and photographing them. And that preserves them because you can only unroll them and roll them up so many times before they begin to fall apart. And now researchers can get a map like this, it's digitized, and it's preserved forever. And there's an aerial view of Crystal Lake. And Crystal Lake, there's an interesting story about it, the tragedy and the comedy. The idea was to construct a canal from Crystal Lake to Lake Michigan. A storm broke the temporary dam, and a lot of water left Crystal Lake, and it dropped 18 feet. It's 51 billion gallons of water flushed out of it. But there was a happy ending, the comedy, the other side of tragedy. It exposed sandy beaches, and it allowed Beulah to be built, and the coming of the railroad and telephone lines, and the development of resorts, and a construction of over 1,000 cottages that line that shore. Let's take a look at some of these features with these historic photos from the museum. Now we have another process over there at the museum. Not only do we scan them for protection, we can also send them to one of our volunteers who will restore them. This photograph you could hardly make out. You didn't know what was there, but this has been retouched. So now we have the original photo. The one that's scanned is a TIFF image for future saving it for the future, and then a third photograph that's been retouched. And there's a moraine on the other shore of the lake. This one was just retouched the other day. It was in pieces, several pieces, and you'll never know that it was in such bad shape. And you can see the shore where the lake used to be, and you can see a moraine in the distance. Here's a good picture that shows Beulah and the railroad. And you can see where the lake used to be, probably over the railroad tracks in a moraine. Sandy beaches exposed when that was a bay of Lake Michigan. Here's a view of part of Beulah looking along the south shore of Crystal Lake. The telephone poles are in, railroad track is there, all because of the tragedy, the lowering of Crystal Lake, moraine there. An old beach, but Lake Michigan was there. Lots of moraines. Everywhere you look, a moraine. But occasionally we get great big piles of sand. Platte Lakes. Lake Ann, that I think is a kettle lake. We'll take a look at Frankfort, Lake Betsy, Alberta. And that whole area used to be covered with Lake Michigan. So you get deposits associated with a lake, and a lot of drainage from the melting ice has affected that landscape, or outwash plain. And right on the north of Betsy Lake is the end moraine called the Man of Sea end moraine. And this is an area where the lake, Michigan, came all the way up to where it says Lacustrine Plain. And that plain has sediments that you would associate with the bottom of a lake. Something like that. More moraines, wireless tower on the hill. This foreground shows the top of the till. There's Frankfurt, not Frankfurt, Hotel Frontenac, and you can see the perch dunes in the background. Let's look at that again. Another view of the Frontenac Hotel. More moraines. Look at that moraine behind that locomotive. Alberta's got their share of moraines. This is looking from Alberta across Betsy Bay to Frankfurt. In the foreground, you can see the Ann Arbor Railroad in the rail yard. Passenger cars and flat cars are in the foreground where maintenance is being performed. Here's a ground moraine in Benzonia that's really good to show you because all of the trees have been cut down. This is at Case's Mill, ground moraine. Let's run over to Honor real quick. You can see where the town is an outwash plain, glacial outwash, where the water, roaring, rushing water cleared out everything. It was flat enough to put a little town in there. And then there's an end moraine on either side. And you can see that house was built at the foot of a moraine. And they're having a party here for the Grand Army of the Republic reunion. And you can see a moraine behind there. This is the Platte River. And the yellow call out shows the outwash plain, the background moraine. And there's Honor. And all those trees on that moraine have been cut down. Here's a cucumber pickle station. The glaciers left the soil really fertile and suitable for cucumbers. So they put them there in those barrels. Here's a really cool cane. In Honor. Remember, that's just a pile of sediment. And they're usually very steep. Moraine there. More moraines. So in these old pictures, you can see these glacial features. The outwash plain, glacial plains, ground moraines, end moraines, canes. Look at that beautiful moraine. Another plain, glacial outwash plain. Here it is in the wintertime, in Honor, in the very same picture in the summertime. This is a view of Honor Valley taken west from US 31. And you can see the rolling, hummocky terrain. This is an interesting photo. It shows maybe a cane and all the trees have been logged. But when you look at photos, the more you look, the more you find. And he's got some kind of a contraption that's bringing water into, it looks like a log that's been hollowed out for that horse. The glaciers that came into the county helped widen and deepen the former valleys that were there. And we have the Benzie River as a product of glaciation. And there's a great big moraine. The Benzie River has been eroding. There's a good example of a glacial outwash plain. Platte River, another example of erosion. Dunes, we've got plenty of those. This is a feature when glaciers grind rock into sand grains, then the lakes will concentrate them and they'll pile up, and then the winds will move them. And we've got some sand dunes down here. And this is an amazing picture. This is just crazy. This is just north of Frankfurt. It's a bluff. And down here, that's all till. But look at this thing. An erosional surface going horizontally. That's your outwash plain that was coming out of melting ice. And it just cut down into the till and made it flat where it eroded into that surface. And then the outwash plain, the water started to slow down. And as it slowed down, it would deposit water, sand and mortar sand and silt. And then the weather changed and it got really windy and it started to blow and it blew a sand dune up on top of that outwash plain. And that's why they call it a perched dune. I couldn't believe it when I saw that picture that shows almost all of Benzie in one photograph, or Benzie, I mean. And some odds and ends to show you the sand dunes. And the winds will create blowouts, and winds will redistribute, waves will redistribute the sand. Here's a really old picture of a dune complex at Point Benzie. This is from 1917. And they're starting to stabilize with grass. And if the wind doesn't keep blowing the sand around and you get enough grass, you'll next get trees. And a modern photograph of some of the dunes behind Point Benzie. They're starting to stabilize, a little bit of water at the surface. Roads through dunes. Then we get, there's the perched dunes that I showed you in the earlier slide. And these are the beaches that we get from Lake Michigan and the result of glacial melting, glacial action. There's a sand dune. So this is an interesting thing to think about. There's a geological feature in Michigan called the hinge line. And here it is. When the ice melted, the northern part of the state, when it melted, the ice was so thick, it started to rebound, the landscape. It started to rise, and it was rising faster than what was down south, that landscape, because it didn't have as much ice. So as this northern part of the state rises, water in those lakes lower, the Great Lakes lower, and the land down south that's not rising as fast, the water is accumulating. So down around Chicago, they're getting water transgression, and up north, we get water that's leaving Lake Michigan. And you get these former ridges, strand lines, ridges, relic beaches. They have lots of names, but that's because the water is being lowered because of that hinge line. As the northern part starts to rise, the water is leaving. And you can see the former beach ridges here where Lake Michigan used to be. And this map shows them here, a topo map. And a Google Earth map shows them. We did a quick field trip on Bookaloo Road, and you can see a beach, a relic or paleo beach cut by a road. This was another interesting thing I found out about is the MQ line in Michigan. The first thing I wanted to do when I started this project was to see what fossils were in Benzie County. There aren't any. There's very few fossils above what they call the MQ line. That's because as the glaciers left, it left a landscape that was barren and harsh. It was called a tension zone. And you didn't have a lot of animals of any kind. What was found was part of a jaw of a beaver, a giant beaver. And there's that MQ line, and it shows the extent of the ice sheets. And up where Benzie County was, it was just too stressed out, that landscape, to support human life or animal life. So there was a mammoth found near Alger, Michigan, and that's just south of the MQ line. And the giant beaver was found near Ludington, which was a little bit above the MQ line. So this brings us to another thing we didn't discuss, and that's the extinction of large mammals. We didn't have them in northern Michigan because of the MQ line, or at least we haven't found any yet. But down south, they disappeared. They disappeared all over North America. And that's because of one of these things. There was overkill. The humans that were around hunted them to extinction. Overchill. There was another cold spell, and it froze them all the large mammals out, all the large vertebrates. And over ill, people that came in from the Bering land bridge brought in diseases. Another theory is death from the sky from a comet. And another idea is massive increase of solar flares. It's still debated. And the people came in either from the Bering land bridge where that blue line is, or along the coast, or both. And I want to move through here. So the first people that come into Michigan were part of the Clovis culture, and they spread pretty far and wide in Michigan. And some of them went by the Sleeping Bear Lakeshore, National Lakeshore, at the Platte River Campground. And they found a small camp there of middle woodland culture, about 400 to 2,000 years old. Now, if you look at that B20, BZ16, those are the numbers that each archaeological site gets in the nation. 20 represents Michigan, that's the 20th state alphabetically. BZ is Benzie County. 16 is the 16th archaeological site found in Michigan. So as of 1987, there were only 16 sites in Benzie County. I called up the the SHPO, State Historic Preservation Officer, and there are now 88 documented sites in Benzie County. And this is what was found at the Platte River Campground. Ceramics have been invented by then. And I made this graph for you guys to see. Most of what has been found in Benzie County is pre-contact, and that's because archaeologists don't know exactly where they fit into the other categories. But they do have one late archaic, but I found another one, and I'll show you this, and then we're going to be done. Jane Perkins, our curator, asks that the volunteers choose a spot in the museum each spring to clean. And I chose to do the Native American display that we have with my mother-in-law. So we were cleaning that, and I noticed that one of the arrowheads looked really different, really unusual. And I said, that really doesn't belong there. And so I did a little bit of research, and indeed it is middle or late archaic. So that thing's laying in our museum, and it's 5,000 years old. Wow, that's incredible. So we have something from the Ice Age. And how you tell is by that notch. The notch is diagnostic. And I'm comparing it with other notches from the archaic period. And you can see it matches that notch in the corner. So I can't wait to see what Jane wants me to clean next spring. And there is where that Ice Age spear point was found. And there's also some burial mounds in Benzie County. There's a village by Crystal Lake. There's a burying mound there by Honor. There's a paleo village there, a mound, another mound by Mendon. And that brings me to the end of our story. Thank you for coming, and I'll take any questions.